Hello classmates, Tim Outland here again. Public speaking class, assignment number 6, demonstration speech. Before this video, I want to say it's not going to make an electrician out of you and it's not going to teach you all the ins and outs of these meters. I just want to give you some basic ideas of what they can be used for and the differences between them if you hear somebody saying analog meter or digital meter. This meter is an analog meter. Meaning it's not digital. It doesn't use electronic display. There's some devices inside that it works against, and it passes a current through, and it'll give you a manual or an analog reading. The scale will sweep across, and then you compare the numbers on the scale against the multiplier that you've selected. And these multipliers are just range selections. You have to manually select what range of the expected voltage or resistance that you expect to see. Older meter. This one's about 25 years old, but it still works great. It measures AC voltage, DC voltage, resistance. It also has a feature where you can measure small current. Again, this is an older device. We'll come back to this one in a minute. Next device, a DVM, or digital voltage meter. As you can see, a 4-number digital display. This one happens to be an LCD. It's a little bit newer device. Just about have to have one of these in modern electronics because some of the voltage that we deal with are fractions of a volt, which are not easily displayed on an analog meter. I'm going to run some first tests for you. A couple of things that you might find laying around the house. One of them being a AA battery. Is it any good? Well, you can do the press the test. Some of them have those, but some of them don't. So how are we going to know whether it's any good or not? Waste of our time. It's been laying in and around in a drawer. Well, we can set this meter up to DC volts. It's going to have an automatic scale on it, and it's going to tell us red to positive, black to negative. And as I read the voltage on this battery, 1.381 volts. This is a 1.5 battery. I don't think there's enough energy in that battery. A little bit bigger cousin, 1.5 volt battery. C cell. Same thing. We're going to positive, positive, negative, negative. Now you'll notice, or maybe you can't, you notice this one is showing 1.597 volts. Now we don't get too concerned about the 0.59, 0.7, even though this is a 1.5 volt. The range of error of this meter is probably about half a volt plus or minus. It's not a commercial test device. I'm not out making precision testing with it, or I'm not trying to make a whole lot of money with it. It's not a professional device whether I can say go or no go on a precision device. If it were, this meter would go out, it'd go to a calibration lab where they would put against a set of standards, and if it needed a fine adjustment to where 1.5 volts read 1.5 volts, they would come in and they would dial out that 0.6 volts, certify it, and then you could use it for scientific type tests or really accurate precision measurements. 9 volt battery. Do the same test on a 9 volt we had laying around the house. This 9 volt battery is only putting out 4.92. Not very good for your smoke detector. You go ahead and do your change on it. Start chirping away immediately if at all. We have another one. Still in the plastic, so hopefully when I bought it from the store. And this one is showing 9.56. So this is a good battery. Going to shift gears a little bit. Going to shut off the digital voltage meter. Going to go back to our friend the old school analog meter. That neat thing about the analog, it allows for quick tests. Don't have to be real precision, although this is the way this was done a lot of years ago. If you want to do continuity checks, now continuity checks are wanting to check the ability of a circuit to go from in and out without a break in it or an open. This meter, as well as the DVM, has a built-in battery power, and when you go into the resistance mode, you put across the 2 probes, you see the needle sweep goes from infinite resistance or maximum resistance, there's no way any electricity can flow through that, it's maximum resistance or an open, to minimum resistance to flow. You touch these two together, you see your needle sweep. Your needle sweep now is down to 0. So there's 0 ohms resistance here. So Right now, there's nothing stopping electricity from flowing between these two probes. Put them between here, now you have maximum resistance, because there's no way that this level of electricity we're dealing with can jump that gap and make the connection. So now we'll come back, infinite resistance. Now what can we do with that? Well, we can make the needle go back and forth until you get bored with that, or you can do something useful with it. Here's a light bulb laying in the drawer. Is it any good? Came out of a flashlight. Well, that one looks like it's going to work. So if I were to pass electricity through here, it would light up. Now what you don't see, or it's kind of hard to see on here, is if I'm checking across this, you see it has about 7/10 of an ohm resistance. And we'll get back to that in a minute. Here's a second light bulb. Now this light bulb, same test. Notice the needle didn't move at all. Now this was a good light bulb earlier today, but it's only rated for 1.5 volts. I decided to hit with 9 and see if I couldn't make it blow up. It glowed very bright for a very short time. That's because the filament inside, the resistance of the filament was not adequate to handle the increased voltage from 1.5 volts to 9 volts. So it blew very bright for a very short time. Well, how does that equate to anything useful further on? Here you have a standard cooking element out of your stove. Works very similar to light bulb, with the exception when this glows red, you're actually cooking food on it. When this glows red, it's in a vacuum so it doesn't burn out so fast. You can see down the hallway in a dark night. This is an element, and inside here, the filament, again, works very same way. You pass electricity in and out, this starts getting hotter. The more electricity you pass through it, the hotter it's going to get, to a point where you can actually cook food with it or keep things warm. We're going to check it. We're going to shut off your stove. Probably also ought to just shut off the breaker to the stove. Unplug the element out of the stove, and then you get these these contacts. I'm going to read across here. I'm going to read across here. Now you notice the needle sweep on this one. It does show that it will handle current, but notice we're up here in about a 27 ohm range, which means this has a resistance to current and electricity flow significantly higher than this one rated for 1.5 volts. This is rated for 220 volts of alternating current. This is rated for 1.5 volts of DC current, direct current. Not enough time in this video to really differentiate between the two. The main purpose of this video is just to familiarize you with these two pieces of test equipment. What's the significance? Well, yeah, okay, we can have an afternoon where we can test batteries or we can test heating elements, but here's something to think about. How many trips do you want to make to the store for a new flashlight bulb? Maybe a new battery. You could spend the afternoon, testing all your batteries. But even more important to your wallet, do you want to have to call out an electrician to do something you did with a $20 meter at his rates, $50 plus an hour? Or say it's a weekend call out. You can't get an electrician, or he said, yeah, I'll come there, but it'll be $200 an hour. Something to think about. Find yourself a handbook, like I said, at the Home Depot, Lowe's. They have electrical device checkout books, basic electricity books. You can get them at the library. You can also go online, YouTube video. These devices aren't that sophisticated. Electricians and mechanics and tradesmen have been using them for years. Electricity is not something you have to be deathly afraid of. You have to pay it respect. But with these devices and this little video, hopefully I planted a seed that starts you on your way. Maybe you can save a little money, or maybe you can impress your friends on how smart you are when you know hey, I know what a DBM is, and I know what an analog meter is. Hope this video helped you. Thank you for watching.